Okay, what if I told you that a key to one of the biggest ideas in science fiction, time travel, might just be hiding in plain sight? In a machine you can find in almost any hospital. It sounds completely wild, I know, but today we're going to dive into that exact idea. Could you actually build a time machine from an MRI?
And really, this is the question that kicks off this whole journey. We're not talking about wormholes or paradoxes here. We're talking about a real, measurable, physical thing that happens inside every single MRI scan. A phenomenon so strange it really makes you wonder, can time's arrow be bent? Even just a little.
So, where does an idea this crazy even come from? Well, it all starts with something called a time echo. I mean, the name itself is incredible, right? It sounds like a signal literally returning from the past. But what is it, really?
The proper scientific term for this is a spin echo. Here's what happens. In an MRI, a signal gets sent out, it completely vanishes, and then, a moment later, poof, it reappears. It's this disappearing act and sudden return that gives it the name echo, and it's the absolute key to this whole fascinating story.
But is it a true echo through time, or is something else, something at the quantum level going on here? To figure that out, we've got to look under the hood and see how this signal is actually made. So let's break this process down step by step.
Okay, stick with me here. This is cool. Imagine a bunch of runners all lined up at the start of a race. Step 1. A radio pulse is like the starting gun, knocking them all onto the track, spinning together. Step 2. They start to spread out, or dephase. The faster runners get way ahead, the slower ones fall behind. The whole group is a mess. Step 3. Another pulse hits them, but this one makes them all do an instant 180 and run back the way they came. Now, the faster runners, who are way out in front, are now at the very back, but they're running toward the starting line. And what happens next? Well, the faster runners eventually catch up to the slower ones, and for one brief, perfect moment, they all cross the starting line together again. That is step 4. That's the echo.
So, and this is the absolute crucial point. We're not rewinding the clock. The runners aren't magically sent back to the beginning of the race. We're just flipping their relative positions so they all line up again for a second. The reversal you see is only happening in what physicists call phase space, which is basically a mathematical map of the system's state, not in the actual one-way flow of time.
And there's this quote that just nails the idea perfectly. It's not about time travel, it's about memory. The machine is essentially listening for a brief flash of restored order, a memory of a time when everything was lined up, right before the inevitable slide back into chaos takes over again.
And that, right there, brings us to the big reality check. Because as beautiful and mind-bending as the spin echo is, it runs headfirst into some of the most fundamental, unbreakable laws of our universe. You see, time, as we know it, has a direction, an arrow, and physics protects that arrow fiercely.
Here's the essential conflict we're dealing with. Down at the quantum level, the math that describes particles is time-symmetric. You could run the equations forwards or backwards, and they'd work just fine. But up here, in our big, everyday world, two powerful forces, entropy and causality, grab hold of those equations and force them to point in only one direction, forward.
So to actually send a message into the past using something like a spin echo, you'd have to pull off two impossible tricks. You'd have to make entropy go down, and you'd have to break the basic rule of cause and effect. Good luck with that.
First up, thermodynamics. The second law is pretty much one of the most solid rules in all of science. It basically says that total disorder, or entropy, in the universe is always going up. Things get messier over time. And while that spin echo creates this tiny temporary island of order, the energy needed to make it happen creates way more disorder in the rest of the system, the electronics, the room, everything. The universe always wins that trade.
And second, we've got relativity. This law is super simple. An effect can't happen before its cause, period. Sending a message to the past is, physically speaking, the exact same thing as sending it faster than light. And that breaks this fundamental rule of causality. Every event in physics has a light cone, sort of a boundary in space-time it can't escape, and this echo is no different.
So yeah, a time machine is off the table. But does that mean this is all just a fun little thought experiment? Absolutely not. Because while you can't build an actual time machine, you can absolutely build a device that lets you watch these incredible principles in action with your own two eyes.
And this is where it gets really cool, where theory becomes something real you can touch. We can just reframe the goal here. Instead of trying to break the laws of physics, let's build a tabletop demonstrator to explore them, to actually see this quantum reversal and the arrow of time clash.
So what would you need? Well, here are the parts.
It's basically a mini desktop version of an MRI. You need a stable magnet, some electronics to send those radio pulses, a simple sample like water to provide the spins, and some software so you can actually watch the signal decay and then echo back. This isn't science fiction. This is real, achievable science.
And what would you learn from it? You'd see exactly how those spins could be flipped around and realigned. You'd watch the signal just completely collapse as the system loses its coherence to the outside world, and most importantly, you'd get this incredible, hands-on proof of why the beautiful, reversible math of the quantum world gives way to the one-way street of time that we all live on.
So, the bottom line is this. The spin echo in an MRI is a totally stunning peek into the weird world of quantum mechanics, where the rules seem to run both ways. But it also shows us why, in our world, thermodynamics and causality are the ultimate bouncers at the door, locking time's arrow so it only points one way, forward.
So, in the end, an MRI isn't a time machine, but the phenomenon that got us all excited, that spin echo. It's like a window into the deepest rules that govern reality itself. It shows us the exact border between the strange, reversible quantum world and our irreversible universe. Which leaves us with one last thought. We can't actually reverse time, but what more could we learn by just listening to its echo?